So now I'm in my geology lab, and one thing to point out here is that when I first graduated from UHD, my professor, Dr. Hogue, was like, when he saw this lab I'm going to show you next, he was super excited. I said, what do you mean? He goes, well, I've never seen anyone draw the surface environment, stratigraphy, and plate tectonics in one image, and you have like the world as a whole shown here. And I was like, well, what do you mean? It's like, no one's done that, James, on this scale before. And I was like, but this is how it should look. He's like, yeah, but people don't do this. So I'm going to tour this for you right now. In general, very simplified. It's just way more complicated. We have India, the Deccan Plateau. We have China here. And then, of course, we have Japan, subduction zone there. And the idea is that it's got general geology of the environment. You go over to the Pacific Ocean, you can see the convection currents going this way. There's, again, it's not to scale. So there's Hawaii on top right there. And you have your, the main shield, the whole shield volcano. The island's getting smaller as the plate goes further away from the heat source, the Pluton here. There's descriptions and definitions everywhere, of course. The East Pacific Rise, and of course, South America. The continental arc where the Andes Mountains will be, basically. So it's a cross section of that one and its site. Then it's the Amazon Basin, very simplified version of that, where you have right here. Now, I'm cutting this point to be South America, Central America, only because my actual undergrad was studying Central American geology. So here's like the Mayan region there, Progreso and all that, where the cruise ships land, basically. And then you go across the Gulf of Mexico here at the salt domes, which most of my undergrad was on this area, the Gulf Coast, and going all the way to the hill country where you have Enchanted Rock. So this is kind of a cutout, basically. Then again, the general North American plate with the Rocky Mountains, the Great Plains, the Appalachian, and the Atlantic. Also want to point out that in the Atlantic, I've shrunken it for obvious reasons. There's the Atlantic Ocean with the Middle-Oceanic Rift right there going to Iceland. And I connected it with Africa, particularly with the diamond mines. The focus here is mainly minerals, so that's why I want to show that part in the Rift Valley, Europe, and the attic up there. And then you go to the Middle East right here with the Red Sea, Middle East in general, and then of course we have the Himalayan mountains right there. Again, a very simplified version of this. So I tie all this together with the rocks and minerals. So there are 4,660 plus minerals in the world today that I know of, at least I've heard of. I have about 175 species here. Each paper color represents a different family or grouping. So the native elements are the ones that are simple: sulfur, copper, gold, graphite being made of carbon, diamond of carbon. The sulfides here are in orange, so it's when you have your sulfur attached to different metals. So we have pyrite, galena, sphalerite. These are all this general area here. There's more pictures that's up close on my portfolio online. The halites are in pink right here, and the models you're seeing here, they are super expensive from a store in New York. I have to save them every so often and buy one, but post-COVID, I'm not sure if the company's still open or not. The sulfates you're seeing here with gypsum and celestine. So you're seeing each island is one individual species, and they're defined by chemical formulas. On the next section, we have all the black right here for carbonates. This one section is just calcite. As you know, there's many habits of calcite, so I have many of them here by comparison. But again, other carbonates you're seeing on here, each one being their own island. Oxides are in green. Hydroxides in yellow, so they're kind of close related to each other there. And we have other groups as well. I have a, quote, organic mineral, which is not a thing, but just kind of give an example, because I teach children and adults and everything. And there's some gems that are unknown and man-made minerals. On this side, we have the arsenates in red, mannanates in yellow, and mannanates in green, phosphates in yellow. And at this point, we are leaving 10% of minerals. The rest of the 90% of minerals, and these silicates are in black here with garnets and kyanite, olivine. We have silicates, which are all here, different groups. And again, each species of talc here with the micas, inosilicates here. And on the other page, we have in the green, essentially not garnet. These are aquamarine, I can't say it properly, silicates. And then we have, you get into the technosilicates with the feldspars in red, feldsporoids in orange, the xenolites in black, and of course the yellow are all of the essentially the quartz groups. On the right-hand side, we'll see amethyst, citrine, smoky quartz, rose quartz, and then the cryptocrystalline side, which is the chalcedony, your agate, all those different things. So they all have SiO2 for the most part. So you're seeing the same mineral being formed from waves. So for this class, it's really chemistry focused, hence the periodic table, health So minerals make rocks, very simple. I have all my resources, my books here, of course, with all of our samples. And the 3 rock types are, of course, igneous, sedimentary, metamorphic. Igneous are here, and this chart was designed by my professor, my mentor, Tom Hobbs, the late, great Tom Hobbs. And the idea is that I've only made a few changes here and there, but it has a bonus reaction series and the minerals that make each kind of rock like that. So you have your felsic to mafic, and also your phaneritic or buried deep plutonic to aphanitic or lava flow. So that's the way of kind of breaking it down. I know it's a very debatable arrangement, but overall, it's like here's a simple way to teach people. Here we have our sedimentary rocks, which I've had most experience with being a fossil person. You have your clastic, chemical, organic, and your bioclastic, or I'm sorry, biochemical here. And the idea is that you're seeing not only that, but from the source to the, so you have like breccia, conglomerate, sandstone, shell, the limestones, you know, the carbonates like that, of course, coal as far as organic like that. Metamorphic rocks, we have 2 areas of foliated and essentially non-foliated, which is a thing, you know, just foliated means heat and pressure increasing. So you go from your slate, phyllite, schist, gneiss, mimetite, and then the other metamorphic rocks here. And the idea is I can show them the origin, parent rock, how limestone makes marble or sandstone makes quartzite. And again, I'm still looking for more samples, but these are large I found in Iton West actually. And finally, we go over maps in general. So the idea of geologic maps of Texas, and my undergrad again is in the geology of Texas area. It's my main focus of study and experience in the field. But in general, we get the entire room. I will go this way, you can stand that way. If you get a broader view, the room is pretty huge and can seat 18 people. But overall, this is a connection between minerals, rocks, then next door fossils. So that's kind of the setup I have here. These are on whiteboards. After this filming, these will go away actually. So this is a one-time, you're seeing this version of it, and next year I'll do a different version of it as well. But thank you for tuning in. This is kind of it. So thank you very much.